Hi everyone, I hope you're all doing well. I'm just getting settled into my new studio. No, I'm kidding. I spent like 20 bucks on, some cloth from Walmart and an old hand-me-down card table. But anyways, the last couple days have been kind of angst-ridden for me ever since I hit the buy now button on the website. And the reason is, as many of you may know, I have several backup power systems in my house. I have a couple of generators, and I have a couple of small solar systems. I have a couple of solar power stations. So I was really kind of wondering if I was going to get enough use out of this to warrant purchasing it. And spoiler alert, I think I am going to be able to use it. Either that, or I'll give it away to somebody to let them borrow it or use it during emergencies. So I know there are a lot of YouTubers out there that actually tear these things down and they bench test them with some legit test equipment. That's great. I watch them too. There's a lot of useful information there. But that's kind of not my style because I pay for these things myself. They're not given to me. I pay for 99% of what you see on my channel myself, so I'm not going to tear it open and ruin it. I'm actually going to get some use out of it or give it to a family member who can. So what I'm going to use is the mother methodology. That's what I call it. I used to take flack as an engineer for calling it that, but you can make the best piece of equipment in the world. If people don't know the capabilities, the end user doesn't know how to use it and what they can actually do with it, that's a problem. So what I'm going to do is, like I said, use the mother methodology. And what that is my mom is 80 years old. If I gave this to her and said, you can use this during an emergency, if your power goes out, she'd be like, that's great. So what can I run with it and how long? So that's my intention in this video, is to go around my house, show you what small electronics and small appliances you can actually use this for, and for approximately how long. I'm powering my appliances, my laptops, my phones, etc. So your mileage may vary depending on the brand, the size, that type of thing, but it'll give you an idea. So as I mentioned, I pay for 99% of the things that I show you in my videos. So if you would like to help support my channel, I'd appreciate it. Please like, please share, and subscribe so you know when I have new videos coming out. And I let it be known in the past, I'm not monetized. I don't make any money on these videos. I do it to help people, although I would like to be able to do more. So if you'd like to support me, please use my Amazon links in the comment section below. Okay, so now let's get right to it, and let's go over what you get in the box and the general features of this power station. So this is the DLNRG brand power station. Now, it may look familiar to you if you've been poking around looking for one of these online. The Go Labs is virtually identical to this, minus the stencil. Now, I know the company DLNRG actually makes the inverter that goes inside the Go Labs R300. So this is the DLNRG 300. The factories will make a run for one brand and then the other. They just omit the tag or the name, and then they put that on later. I think it's, if I were to put money on it, I'd say it is 100% identical to the Go Labs. This one with the coupon went for $180. The Go Labs, for comparison, with the coupon is about $200. So you save yourself about $20 by going with this brand. So now let's go over some of the basics, what comes with it. You get a wall charger. You get an automotive charger, and you get a MC4 connector charger that connects to a solar panel. So 3 ways to charge it come in the box. It also comes with manual, and you can also charge with PD, USB-C PDs, up to 60 watts. So let's go ahead and get to the features. So as I mentioned, I'm not going all bougie on you. I still don't have a pointer or anything crazy. So what we have is, you have the main power switch over here. Press and hold it, it comes on. And you have your LCD screen up at the top. Over here you have your, let me find it, the AC on-off button. Prior to using the AC outlets, you have to press and hold this to turn it on. And then it activates the 2 outlets down here. Now these are 110 volt, 300 watts AC output. Then you have under your LCD screen, you have your USB on and off, and then you have two USB-A's outputs, and these are 3 amps apiece. Down below those USBs, you have your USB-C slash PDs. The first one is a USB-C PD 30 watt, and the other is a USB-C PD 60 watt. Then you have your DC on and off. You have two 5.5 millimeter DC ports. Then you have your DC input for charging, and that's also a 5.5 millimeter. The max you can pull from your DC circuits here in total is 12 volts, 10 amps. Now, as I mentioned, you have your on-off switch over here, and then you have your automotive plug, input and output jack. On the back, you have your light switch. I'm not gonna hit it now because it'll blow out the sensor on my camera. And it's a multi-mode light with high-low blinking. So you're typical for a power station. You can see on the sides, you have your ventilation. Your air is going to be pulled through to cool the inside of the unit. The build quality is really solid. I haven't really found any issues with it yet, but I really haven't put it through the ringer yet, so I've just been playing with it a little bit, but I'm going to test it here over the next day and making this video, and we'll see what issues we have, if any, as far as charging and or discharging, using it to power devices. Okay everyone, so here we're doing the field testing of the DLNRG 300 watt solar power station. So what I'm going to do now is start at the bottom and kind of work my way up with some of the easiest things and the most likely things that people will be charging with this. So the first thing would be a phone. So I've turned it on and I've got my USB power button on, so we should be good to go with that. As you can see on the display, I don't know if I showed this yesterday, but it shows the charge percentage. It shows the hours left until empty, and it shows the amount of wattage being used. So we're going to go ahead and start with an iPhone. You can see it's pulling 10 watts. If I were to leave this on, it's doing the calculations. It would give me 30 hours until empty, 29. It's going to keep recalculating as the power is drawn from it. But anyways, like I said, I've done the calculations on this, and I can get 20 to 21 charges on my phone. So the next item is a Fire tablet. I highly recommend these during power outages. You can keep documents on them via a small SD card, a micro SD card, important documents. You can keep movies and that type of thing, just for some basic entertainment or some reference if the power goes out. So we'll go ahead and charge this. And it's funny because the battery in this is actually smaller capacity than the battery in my phone. So where on my phone I would expect 20 to 21 charges, I can actually expect 25 charges from this. You see the wattage is actually a little bit lower that it's pulling to charge, and the capacity is lower, so it won't take as much juice to fill it. So those are all the USB devices that I'm going to actually show. So now we're going to move on to AC. And those are all things that you plug in. And the focus of my video is going to be on items that you'd probably use in an emergency scenario if the power was out, say. Now I actually ran this down to empty. The battery capacity is rated at 299 watts. That is not necessarily true because everything comes with a cost in life, right? So there are electronics in here, there's control circuitry, and there's the display, and there's a conversion factor to change the DC from the batteries to AC. That takes a little power too. So the actual capacity came in at about 260 watt hours. I'm going to actually change that to 250 just for the sake of math and to give it a little fudge factor. We're going to base our calculations off that 250 watt hours, and we'll see how many hours that each one of these units will go. So this particular item is a Midland weather radio. So we've gone ahead and plugged it in. So you can see it's reading 0 watts. That's because it's using less than 1. It'll fluctuate between 0 and 1 because this is a very high efficiency receiver. So this will give me approximately 10.5 days if I were to run it just nonstop, right? But if your power went out and there was a tornado on the way or a hurricane imminent, you might want to run this thing. So this is a good way to do it, to know what's coming. So the next item we're going to check out is another way to actually pull in and receive information during an emergency, and that is a shortwave radio. So let's go ahead and plug it in. We will turn it on.
To register, visit runsignup.com.
You can see this is also a very efficient radio. It will run on batteries as well. It usually uses less than a watt, so you'll see it will go 0 watts. It will fluctuate up occasionally to over 1, but this will give me about the same amount of runtime as the weather radio. So very efficient. You come and you can let this run for days and days. This will go 7 to 10 days, no problem. If you left it on all the time. Really good. The next item is a basic LED light. Now, this does have the light on the back, right? And I would actually utilize that as much as I could because that's the most efficient. But if you wanted to run that in one room and then run an extension cord, say, to another room, and you wanted to use an LED light, this is, let me show you. This is just a basic LED desk lamp that I've actually modified to put over my workbench. Now you can see the LED light is pulling between 2 and 3 watts. I noticed that it doesn't really round up, it rounds down, which is a little odd to me, but I imagine that's pulling closer to 3 watts, but it says 2. So as far as that light goes, it'd probably go close to a week, no problem. So now, the next item is a handy talkie. This happens to be a Baofeng UV5R. If you're watching this, you're probably familiar with these or at least heard of them. So to be able to charge this and recharge it, we'll see what the wattage is for that. So yeah, it's climbing up. It's about 3 watts. And I've done the calculations as far as the battery and the watt hours that this provides versus the battery capacity on these radios. And my calculations tell me I can recharge this about as many times as I recharge a phone. That's about 20. So I should get 20 full charges out of this unit to charge that Baofeng UV5R. Should be able to do it. All right, the next item is I have plenty of flashlights around my house. If you see my other videos, you know I'm kind of a flashlight freak. I use rechargeable batteries, generally Eneloops, and I recharge them via charger. This happens to be an ambient weather charger. Now, I'm not even going to plug this in. I'm just going to tell you you can do it because there's too many variables with the batteries that you use, right? There's regular capacity, there's high capacity, but you should be able to recharge a full complement of batteries, which is 4 in here, multiple times, given the capacity of this unit. Now we're moving on to some bigger things. I say bigger because they generally use a little more energy, and one is an air purifier. Now I know some people suffer with allergies. I have people in my family that do, so we utilize these in just about every room of the house. So we'll go ahead and plug it in. See, we're climbing up in our energy demand here, how much we're going to need. So let's turn the display on so we can see what's going on, and we'll turn it on to low. Okay, so we're pulling 15 watts. Now I'm not sure, but it appears to me after I've utilized some of these items that maybe the watt meter on here is calculating a little bit on the low side. I calculated 8 to 12 hours depending on the high, medium, or low. You'd be able to utilize that overnight and recharge this if somebody was really suffering from allergies. It's good to know that I can actually pop this in the bedroom along with the air purifier, let it run overnight, and hopefully give somebody some comfort. Now on to the next item. This is actually the last item we'll be testing on the bench. This is a 260 watt heater. So we're really going to put this thing to the test and see how it goes. Hopefully it can handle it, but we shall see. Here goes nothing. Let's go ahead and fire it up. Well, let's get our display on first so you can see what's going on. Okay, so the fan's just kicked on. Oh, we're getting up there. I'm not sure if this is going to take it. 286 watts, 278. Okay, so when the element first came on, it spiked a little bit, and it should go down. I think I have this rated at about 260 with my kilowatt in the past, so I know what to expect. So yeah, I think that is reading a little bit low. It is coming out hot, and this is keeping up, and it's got the fan going to cool it. So I'm actually impressed. I thought this might choke it, but it didn't. So that's a good thing. Given the capacity, I calculated about 250 or 260. It's going to run for about an hour. So not really enough to heat a room or anything, but if you were in a small tent in the middle of your living room, if your heat was out and you wanted to warm it up, this would actually do it. For about an hour. It would keep it toasty warm in there. So now let's move on to the bigger, and I like to say fun stuff, because I like to push the limits of this thing. Let's check it out. So what we have here is a 19-inch LCD TV and an over-the-air HD antenna. We're going to go ahead and plug this in. Let's turn it on. Now this is what we'd most likely use in the event of an emergency, because it's the most efficient TV that we have. You see it's pulling 23 watts. So at 23 watts, you're looking at approximately 10 to 12 hours. So now let's go in and check out a bigger TV, a 55-inch, because that's what everybody's accustomed to these days, right? So let's go give that a shot and see how long we could go with that. Now some things that you won't be able to run, obviously an air fryer, that's a no-go. Phone or an Echo you'd be able to do if you wanted to. Coffee makers, don't even try it. This thing will not do a coffee maker, I guarantee that. Now what if you wanted to go a little bigger with your entertainment goals? This is a 55-inch LED TV. Let's get her turned on here. We're pulling about 53 watts. It'll give us about 5 hours. You could throw a DVD player on there if you wanted to. We actually use the Wii. You can play DVDs on the Wii. So I'm going to plug in the Wii along with the TV. Fire it up. So there you are. You're looking at about 68 watts. And the actual, I don't know if you can hear it or not, but the DVD inside is actually spinning. So that would simulate playing something. So if you wanted to run a 55-inch LED TV and your Wii, you're looking at 70 watts. That would give you about 4 hours, maybe a little bit under that. Nice way to go through if you only have a short power outage, play some games, watch a movie or something. Now, as far as continuation of internet services is concerned, you're going to have to power your cable or DSL or fiber modem, as well as a Wi-Fi access point, unless you have an all-in-one. And generally, the modems run up to 25 watts. So I would count on that value in your calculation, right? 25 watts for that, and it's about 10 watts for a wireless router. So you're looking at up to 35 watts. It could be less than that 35, but it's a good baseline. You're going to get 7 probably to 10 hours depending on what model and make of modem that you use and your router as well. So let's talk laptops. Laptops vary from make to make, model to model. So this happens to be a 150 watt unit, but I think it actually runs on 45 watts once it's fully charged, unless I'm doing something very intensive, and then it'll ramp up if I'm doing video editing or gaming or anything like that. So let's go ahead and see what it's pulling now. Right now at idle, with nothing going on, it's pulling 25 watts. That would give me approximately 9 hours. If I went to recharge this, I could probably charge it 2 to 3 times. All right, now let's really put this thing to the test. Let's go out and try a freezer and a dorm fridge and see if the compressor kicking on will kill this unit or if it'll handle that surge. Let's check. All right, so let's have some fun. We're all set. We have a 5 cubic foot chest freezer. Getting ready to turn this on. Now, if you've seen my other videos, you know that I've run this in the past with my 500 watt unit, and that had no problem with it. But now we're going to try with the 300 watt. It's a little smaller. I'm going to see if it can handle the peak of the compressor kicking on. But let's plug this sucker in and find out. So this should be fun. Ooh, that's not good. Okay, let's go back over to the freezer. Let's try this one more time. All right, we're going in. Are you ready? It aired out again. Obviously, it does not like the compressor kicking on, so we can rule out the freezer portion of the test. I was actually going to try it on a little dorm fridge as well, but this uses more energy than the freezer. So if the freezer doesn't work, when the compressor kicks on the fridge, it's not going to like that either. So we're going to go ahead and back off. And it's almost lunchtime, so we're going to go ahead and try to cook something here. See if this will handle a small, slow cooker. And we'll make ourselves some lunch. All right, so I am going to pretend this is a cold winter day. It's not actually. I live down south, and it is brutally hot and humid out. So we have a small Bella crock pot. I believe it's 150 watts. So this unit should have no problems whatsoever with it. We're going to go ahead. I put some cream of chicken soup. I'm going to have some cream of chicken soup and dump a bunch of crackers in there afterwards and have myself a nice little lunch. So let's go ahead and fire it up and see if this thing can handle it. Okay, we got it on low. Hopefully you can see with the glare. We're at 56 watts. But you know what? We're not slow cooking this, man. I'm hungry, so I am going to turn it up to high. All right, so we're showing 100 watts. Let's leave this on and come back in a little bit and see where we're at. So it's been about an hour now. We have our slow cooker running. Let's turn on our display, see what we got. It's still running at about 100 watts. The soup is bubbling hot. So I'm gonna get some crackers and enjoy that. But as you can see, this R300 is capable of running the small crock pot and heating up canned goods, etc. So you have some options to heat up meals in the event that the power goes out. So not only can this recharge small electronics and power some small appliances to keep your radios going, recharge batteries, run small appliances, keep your internet going, keep entertainment going. There's a lot of possibility with this little unit. So after putting this through its paces, I was pleasantly surprised. There's a lot more items that I can run around my house than I initially thought. So if you just want to keep the entertainment going, or make a quick meal, or charge up your small electronics to get you through a couple hours of brownouts, or if you found your power out in the middle of the night and you live in a cold weather environment, I would actually get a 12-volt electric blanket. This would run that for, depending on the brand and the size and that type of thing, the specifications. You can get one that's generally runs on about 50 watts. That would get you, 5 solid hours with this. So that would be an emergency use that also came to mind while I was testing. Now it does have pass-through charging, which is great. The only issue with that, I found out, is that 60 watt PD USB-C port, the circuit actually opens, which means it doesn't work, right? So you cannot pass through, charge, and use that port to power anything. The other ones work fine, just not that one. So that's kind of a pain. And additionally, the charge time was a little bit slower than I expected. It's going to take you a solid 6 to 8 hours to charge this thing up, no matter which method you use. So all in all, pretty good unit. I'll put links to this and other portable solar stations that I recommend below. And hope to see you next time. Thanks for watching my video.